All right, guys, welcome back, and we are going to continue our discussion on SQL or SQL today. So let's just get on right on into it. So it's nice early morning, so we'll just go ahead and get started straight away. The plan for today will be to do in the first hour, I will do the slides, and then in the second hour, and just get to wherever we get to with that. And then in the second hour, I will pull up the MySQL database again, and we'll kind of run through some examples of how we might use SQL statements to access our data. Okay. All right. So let's see. So this was where we left off. Was we had this whole the OR. All right. So it's not a pipe. It's not a double pipe. It's not a special operator. Right. It's a keyword. So it's a reserved word in SQL for OR. So just the word or the word and. So you could say where city equals London and something else. Maybe there might be some other information we're wanting to get from the branch information. So I might say, so I'm looking for a student that where their department is the computer engineering department and their year is 4. So I'm looking for all 4th year computer engineering students. All right. So I could write the word and in there and use it that way. Okay. All right. We can also use and as part of a range search. So what we're saying here is we're saying we want to get a salary that is between 2 values. Okay. Now, unlike that greater than symbol, the between for the range search includes the 2 endpoint values. So we're saying we want the salary to be between 20,000 and 30,000, and we want to include both 20,000 and 30,000 if they exist. So here we have this John White, a person who's a manager making 30,000, whatever, euro, lira, we don't know what that is, right? It's a number. Again, this would be a type of situation like yesterday we talked about data is not the Clifford Stoll quote, data is not information, information is not knowledge, knowledge is not understanding, understanding is not wisdom. In the same way that this 30,000 would represent data, right? But we don't know what it means. It means 30, it just means it's just a value. We don't know, is that lira, is that dollars, is that euros, because those are quite different, right? All right, so that would be a next level. More information can give us more data can give us more information can give us more understanding and so forth. Okay, and even if we knew that this was, let's say 30,000 euro, because this is a British or pounds, but let's say 30,000 euro because this is a British curriculum system textbook, right? What is 30,000 euro? What does that mean? And the column tells us more information. Salary. So now we understand. But even the computer doesn't understand what a salary is. The computer doesn't understand what a salary is and what 30,000 is, and it just stores all that information, right? It's up to us to kind of give meaning to what those things are. Okay. So a little bit of philosophizing this morning. Maybe I haven't had enough coffee yet. But the point of this slide specifically is to help you understand that we can use the between reserved word along with the and reserved word to get a range of values. All right. We could have also written this query like this. Okay. We could have also written it with the greater than or equal to 20,000 and salary is less than or equal to 30,000. That would have been fine. That works the same, right? Also, what you'll see in a number of these slides is this comment about there being a negated version, not between. So if we would have said, where salary not between 20,000 and 30,000, then we would have gotten all salaries strictly less than 20,000, and all salaries strictly greater than 30,000. Okay, so we can use the not between to get things that are outside of a range of values. Okay, so you're going to see this a lot. You're going to see this comment on a lot of our slides here that says there's a negated version, just meaning that we can get stuff that's in a set or in a range or in something. We can also get something that's not those things as well. Okay, so just by using the not keyword, the not reserved word. Okay, all right. We can get things that are in a set of values. So here we could say where position is in the set of manager and supervisor. Okay. So here, notice when we get the results of this query, all the position values are going to be one of those two, manager or supervisor. Same here, there's a negated version. You could say not in. You could say I want everything that's not in this set. Okay, so you would get everything that's not one of those two. All right. In the same way that you can rewrite it in a different way, where you could say where position equals manager or position equals supervisor. But this could get to be very hard to type this over and over and over again. Position equals manager or position equals supervisor or position equals clerk or position equals, right? So that could be very tedious to type that over and over again. So the set membership usage like this can be easier to understand in a situation like that. Okay. All right. So again, n is more efficient for typing when the set contains many values. So if there's lots of values possibly in the set, then you may want to use the n instead of trying to say where it's equal to that value. Okay. Make sure here that you know that the way to do something could be multiple values like manager or supervisor, that you understand that you set that in a set type of notation here, or you use this position equals manager or position equals supervisor. I've had a number of students in the past years who, when I've asked a question related to how do I get all results where the staff person is either a manager or a supervisor, they will write where position equals manager or supervisor. All right, but that's not right because SQL can't do that. SQL can't, does not understand what you're trying to do there. Okay, so make sure you know that you either need to do position equals manager or position equals supervisor, or you can do it this way with the in a set of values. Okay, let's see. There's a question, comment. Okay, yeah, okay, so you're asking about the salary value. It would be better to store salary as a numerical value, mostly because we oftentimes want to be able to do calculations. Like if somebody gets a 10% raise, for example, we want to be able to calculate that and restore it as the new value. And we'll see how to do that in when we get later in this set of slides. But what I would say what most systems would do is that if there is a possibility that a person's salary could be represented using multiple different types of currency, like maybe you might have an international company that pays some of its employees in euro, some of its employees in dollars, others in lira, something else in pounds. There's all kinds of different currencies that might be getting used. Then what they will probably do is they will probably have one column to represent the salary, the numerical value, and another column to represent the currency type. All right, and then that way you don't lose the ability to do numerical calculations on the salary because it is a a numeric field, but at the same time, you still can have multiple types of salary. But Ali Matahan, you are also right that if your database is only dealing in one type of currency, like let's say for example you have a Turkish company, they only deal in lira, then as far as like salaries of employees and stuff, then yeah, they would not need that extra column because everybody would be being paid in lira, and so therefore they could just have it as be as part of the user interface. That's right. Yeah, good questions there. All right, so we're done with set membership. Okay, one of the coolest things for me, one of the neatest things that SQL can do is it can do this pattern matching. So if you've ever done any kind of what's it called? The system administration, or you ever worked with command line stuff, and you do, search for, something dot star or star dot text, and you're trying to use a wildcard, right? To say, I want all files that end in dot txt, for example. That star is a wildcard. So in the same way for SQL, this percent sign acts as a wildcard. So basically, what we're trying to say is we want to get these columns from this table, and we want our condition to be the address needs to have 0 or more characters before this set of characters, and then 0 or more characters after it. So we're saying we want the address to be like Glasgow. So we're trying to get all owners where if in this particular example, the address is stored like this, where the entire address is just stored as one long string of text. Okay. Now, so what we're saying is any number of characters before, then the word Glasgow, then any number of characters after. And this percent, it can be 0 or more. Okay, which means I scrolled up too fast. Okay, which means the string could start with the word Glasgow, and that would be okay. We would still get it. The string could end with the word Glasgow, and we would also get it. Okay. The string could be just the word Glasgow, and we would get that as well. That would return as well. Okay, but anything that doesn't have this in it, all right? Anything that doesn't have this word in it does not get returned. Now, what would happen if somebody lived in London and there was a Glasgow street in London? They would get returned because even though they live in London and it's not really what we want. Right? It's not really what we want. We didn't want somebody that lives in London, but because we made our query look like this, we would get anything that would include those letters. Yes, this is helpful for searching for things, for searching for strings that are of a certain type or have a certain value in them. So let's say, for example, I wanted to search for all students named Mehmet, for example. I could do that using this pattern matching, right? Because some people are named Mehmet, and some people are named Mehmet John, and some people are named other things as well, right? So there are, but if I wanted all students that had Mehmet as part of their name, then I would use this. I would use this type of format, okay? All right, there's a couple of different things about this wildcard stuff. So there's 2 pattern matching symbols we can use. One is this percent sign, which means 0 or more characters, and it can be anything, any types of characters, right? It could be spaces, it could be printable characters, it can be anything, okay? And it can be 0 or more. We use underscore to mean any single character, okay? So it has to be a character there, but it can only be one, okay? So so if we did underscore Glasgow underscore, then what that would mean is we were saying we want anything that has a single character, could be a space, anything that has a single character, then Glasgow, then another single character. And that's kind of not what we're wanting here, right? Because then it would only be then if anything existed before that, if any more characters existed before Glasgow or any more characters existed after Glasgow, we wouldn't get those results. All right. I'll show you an example. We'll do an example with the underscore during the example section today, because this is a very important, for me, this is one of the more important aspects of SQL that you need to understand, because it's powerful, it's useful for searching, as was stated. And one other thing about this, if you're using another database utility, this might be where some of the differences are. Okay, so for example, in Microsoft Access, the symbols are not percent and underscore. They are, one of them is a question mark, but I cannot remember right now. I cannot remember right now directly which one the other one is. Right, but I can look them up during the break. But Microsoft Access uses a different set of characters for their pattern matching symbols, and I'm not sure about some of the other database utilities. I do know that Oracle uses percent and underscore like this. So MySQL and Oracle both use the same. Okay. All right. Now, remember we talked about null being this special value that's not nothing, it's not zero, it's not spaces. It's this special value that means we don't know, meaning we don't really know information about this. So the example I gave yesterday was somebody you try to sign up for an account on a system, you leave the birth date blank, and it just doesn't store your birth date. It doesn't mean that you don't have a birth date. Everyone does, right? But it just means that you didn't give them that information. Okay, so the problem is that if we try to say something equals null, if we try to say, okay, I want where comment equals null, if we didn't do the is here, then what would happen? It would say, it would give us no results because nothing equals null. Because remember, nulls we don't know. Okay? So, and I'm going to do this on the whiteboard in just a moment because I think it's this kind of can be a tough situation, tough thing to understand. So what we're wanting to say is we're wanting to say where the comment field is blank. And we can't just say equals null because again, it doesn't equal null. Nothing equals null, not even null itself. But we can say where comment is null. So we have to use this special reserved word to say, is the comment the null value? Like, is that's what's stored in the database for this field? Okay. So we can say, I want the client number and what date they viewed it where they didn't put a comment. Okay. So we would get something like this. Okay. I will go ahead and switch over to the whiteboard app. Let's see, it's taking a second to come up. Let's see. All right. Because I do want to show you some stuff about how this null is null and all that stuff works. Yeah, the whiteboard in class comes up a lot faster, doesn't it? The physical whiteboard if we're in a classroom comes up a lot faster. Which is up. Okay, I'm not sure which that one. Just the program just decided not to come up. All right, well, I'll try again, but let me go ahead and continue on for now and see if I can get this whiteboard back up while waiting for that. Okay, so one thing I do want to go ahead and say is that this is not null as well. That can test for non-null values. So if we wanted to get all examples here, right? We wanted to get all clients, all properties, and we wanted to see all the comments that people posted when they viewed that property. We could say where property number equals whatever and comment is not null. So the negated version says, okay, only give me fields where there is something to view. Okay. All right. So that would be, we could also use the is not null. And it looks like the whiteboard finally came up. So let me try to share it. Okay. All right. So what I was trying to get at is we have a couple of different confusions that can come up with this whole null thing. And one is we might say where column equals, no, we might try to say this, right? Issue. Oh, is it not sharing the whiteboard? Let's see what. What do you guys see right now? Oh, that's not good. Ah. Hmm. Okay. Well, that's not good. So, did the slides come up? Like, if I pull up the slides here, do you see? That looks like the program's having issues. Looks like the Microsoft Teams having issues. All right. What we'll do then is I'll end this meeting and restart it immediately, and we can continue on from there. Yeah, well, let's try that. I'll try leaving but not ending the meeting and then rejoin. Boy. Gosh, come on. What's going on? All right, are we back? All right. Are you guys able to see? All right, let's hope we can not have that happen again. For some reason, it even when I went to go rejoin the meeting, it closed out the Microsoft Teams app for some reason. That was weird. Okay. All right, so what you should be seeing now is you should be seeing the whiteboard, and I've typed on here this column equals null thing, right? Okay, so hopefully that's what you see. Now, okay, let's say. Typing out some different ways that we might think that we need to say something. And some special ones here at the bottom. Okay. So the reason why I wanted to give you these examples here is because they can be some common ways that we might try to write these. Okay, try to look for null values or something like that. Now remember, the main thing that we're using this as, we're using this in a where clause. We're using this in the conditional part of the query, right? So it's kind of like an if statement, right? So what we're wondering is this going to be true or false? Okay, is this going to be, is the column going to be a null value? So when we use the column form like this, what I'm saying is, you know, where we said comment equals null, birth date equals null, you know, that kind of thing. Okay, now I want to go through one by one and tell you and explain why this is or is not the way that we would do this. Okay, so this one, we don't want to do it this way. Okay, because nothing equals null. All right, we don't know. Remember, we don't know what null is. Null is unknown information. So if we try to say it equals null, this will always be false. Okay, no matter what the column value actually is, even if it is blank, even if it is null, it will not equal null. Okay, this is good. Oh, I do need to make one change. I just realized I typed something wrong here. Okay. All right. For the same reason that column equals null is not the appropriate way to do this, the same way is we can't do it this way either, because even if the column is full, even if the column has a value or if it's null itself, we don't know that it's not equal to null, right? So this it's if we give this, this will also be false. So regardless of the value in the column, both equal null and not equal null will be false. Okay? Because this is not the way that we assess for null values. Okay? If we want a column that has a value in it, we need to use this is not null format with the keywords is not null. Okay, and these are some special ones I wanted to give over here because let's talk about just, is this going to be true or false? Because this doesn't involve column values. This is, you know, this is just you know, this is just, we could put this as part of a where clause. This would be like saying, you know, we're trying to say is, you know, is true equal true, or is false equal false, or is, you know, 0 equals 0, you know, something like that. Okay. But the problem is that the way that the null value is treated is we're saying, is the unknown value equal to the unknown value? Well, we don't know. It could be. It might be. It might not be. We don't know. So when we execute a query that would have, if it had this line in it, this part of the where clause, null equals null, it would always come back false. Okay, because unknown, we don't know if it equals some other unknown value. Okay, but in the same way, null does not equal null. Well, does it equal? Does it not equal? We don't know. We don't know. It could be. It might not. We don't know. So this is also going to always be false. So this is the one that can get kind of confusing for a lot of us, okay? Okay. Is we say, wait, how can it be equal is false and not equal is also false? That seems to violate logic. And the problem is that it is because this is not the correct way to tell if something is null or not. It's basically saying, does null equal null? Does unknown equal unknown? Well, what's the unknown value? We don't know. What's the other unknown value? We also don't know. Are they equal? I don't know. I mean, if you meet two friends, at the restaurant, and you don't know what age either one of them is, do you know if they're the same age? Well, no, just because I don't know what John's age is. I don't know what Ezgi's age is. Are John and Ezgi the same age? I don't know. All right. But in the same way, are John and Ezgi not the same age? Are they different ages? I don't know. All right. And so that's why these are both false. So what we need to do is we need to use these is keywords, is not keywords, because null is null, that is going to be true. All right, because unknown is unknown. Yes, that is true. And in the same way, null is not null, unknown is not unknown. Nope, that's false. All right, because unknown is unknown. Unknown is not unknown. Cool. Unknown is not known. All right. We don't know what the value is. It is unknown. So this is the true right here. Okay. All right. Again, I've probably given you a couple things that may have cleared some things up, but probably also give you some confusing things as well. The main takeaway, the main thing I want you to take away from this is when we are operating with nulls, that when we're trying to find unknown values, blank values in the database, we do not use the equal sign or the not equal sign. Okay, don't use those. Don't use these. Okay, make sure you use the is and the is not to find blank and non-blank values. Okay, can we agree to that? Thumbs up. Everybody, if you understand that I'm saying do not use equal null, use is null to find blank values, give me a thumbs up in the chat. All right. Make sure that you understand that at least. No. Oh, do you have somebody with their hand raised? Okay, yeah. NS, Bashar, you guys have your hands raised here? Do you have a question? Fatih, Furkan? Oh, you're raising your I see. You're raising your hand to give me a thumbs up. Okay, good. Sweet. Okay. Good. I don't know if that's going to get recorded or not. I don't know if that's going to I thought maybe you had a question, but I don't know if that's going to be a part of the recording or not. So, all right. Guys, if you guys don't tell me otherwise, I will assume that you understand the things that I say. So if you do not understand something, you have to let me know, okay? The reason why I went through this null thing so much is because it was the hardest thing for me to understand when I first started programming database. Oh, Ali Metan, it's just an example column. Like, in a real example, we would say, salary is null, or we would say comment is null, or birth date is null. It's just an example column. Okay, so yeah, so but this is null, and why does equal null, like especially this stuff down here, like that was the stuff that was hardest for me to understand when I first started doing database interactions. Is column equals, I mean, what is column equals? Oh, like just a space. Like if you said space. Well, if the column had a space in it, just a space character, then that would return true. All right. If you were looking specifically for a column with a space in it. So, for example, I'll give you guys a good example of a null situation in a real world, in a system that you have used. Okay, so you know that in what is it called? In right in the OBS system, in order to get your grades, you have to write a comment, right? Right. But one thing is, it does not allow for you to have a null comment. It doesn't allow you to leave a blank, does it? You need to type something. And so what I would like to do is but so what I see is I see a lot of comments like this. So I try to filter. What I would like to do is try to filter out comments like that, right? Because that's a meaningless comment, right? But I think what you're saying is, what would happen if it did, where you had like this actual space between them, right? Right. Then what it would look for a value in the database that was a single space. Okay. But I think that the OBS system, because I've never seen that as a comment on one of my courses, so I think that the OBS system must have a trim on it or something like that that prevents just a single space from being put in as a comment. So, because I think some of you probably have tried to put in a single space in, and it tells you that you didn't put in a comment, right? So, but nobody in this class, you guys don't do stuff like that. You give me good, real comments, right? This will come up later, by the way, when we start talking about column constraints. Null is not null column constraints. I'll bring this up again. This is a very important thing for me. Okay. Hopefully that's clear then. Hopefully we cleared that stuff up. So let's go ahead and I just have a few more minutes. So let me go ahead and pull up the last few slides here. Where are you? There you go. All right. A couple more things we want to discuss on this SQL stuff before we end the slide portion of the day. As we can also order things. We can say, I want to order by salary, and there's an extra word we can put here, this descending. So what we're saying is, I want to order this result by the salary column descending, so from larger values to smaller values. Okay. Automatically, by default, if we don't have that descending word here, DESC, it's going to automatically order by ascending, by smaller values to larger values. So type flats, then houses. Okay, and notice that the string, the text type, is ordered in the same way that we talked about strings in Java, where it's basically it's alphabetical. But remember, a lowercase f is considered higher than a uppercase f. All right, because it's using that ASCII stuff. So if we had a random type flat with a lowercase f in here somewhere, what would happen is that one would get moved beyond the capital H houses. Okay, so remember that uppercase numbers have lower ASCII values, lowercase letters rather, have higher ASCII values, so therefore they come later. Okay. We can order by 2 columns. Right. So what'll happen is we order by type and then by rent descending. So we want to get all the types. Right. So we're going to order everything by type first. So flat, then house. Then we also want to order within those, right, by rent descending. So notice here it's all the flats are together, then all the houses are together, and then within those groups, all the rents are descending. So we do 450 down to 350, then 650 down to 600. Okay. So we order by the type first, and then within those groups, we are going to order by the rent. Okay. This is very useful. So, for example, if I had a database that had all the students in the class, and I wanted to order by type of, because some of you are graduate students who are taking this as a preparatory class. Some of you, most of you, are undergraduate students. And let's say I wanted to order by type of student first. I wanted to order by graduate student versus undergraduate student. I wanted to do that first, right? And then after that, I wanted to order by, say, your name. Okay. So now I would get a large group of undergraduate students ordered by name, and then a smaller group of graduate students also ordered by name. Okay. This might be a useful way to be able to do that. Okay. All right. So we can order by multiple columns. There's no limit to how many columns you can order by. You can order by all the columns if you want. And one other big note I want to make here, and when we'll finish off on the next section. Okay, I do want to get into the next section of the aggregate functions, because that's an important place to end on. The order by, we can have as many columns as we want, and we don't have to have them be as part of the select. So let's say, for example, I wanted to get I wanted to order by type and rent, but I don't want to see the type for whatever reason. That's okay. I could just say property number, rooms, rent, from property for rent, order by type and rent. And then what will happen is it will just take this column and it won't show it to me. It will still have everything ordered the same, right? The property numbers would be in the same order. The rooms would be in the same order. The rents would all be in the same order here, but it just wouldn't show me this one column. And that's okay. All right. So again, we'll finish off on the aggregate functions here. I do want to go ahead and do this because one thing that's very, very useful in our database queries is sometimes we want to be able to aggregate values together. We want to find, we might want to find what the minimum rent is of something. We might want to find out what the maximum rent is. We might want to find out what the average salary of our company is. We might want to find out what the total salary of everybody in the company is to see how much are we spending in salaries for everything. We might want to count the number of values. We might want to count the number of employees in the employee table or something like that. Okay. Now, count, min, and max. We can use that on any field, basically, any type of field. Non-numeric, numeric, doesn't matter. because a string can have a minimum value. Like we can have a minimum string, right? We can have a maximum string. We can have a count is just the number of columns that have a value. Okay. Count star is going to be used a lot. Again, just like I said, you'll use select star from table a lot. You will use select count star from table a lot as well, quite frequently, to find out how many rows are in a table. Okay. Count star counts all of the rows of the table. Doesn't matter if nulls or duplicate values in a certain column occurred. Okay. All right. We were talking about sum and average can only be numeric fields, so we cannot average a set of string values. All right, because that doesn't really make a lot of sense, and we cannot add up string values. Okay, so one thing is a couple of things here is if we have an aggregate function, right, we cannot reference a column on its own as well. We'll see in a moment. We'll see in a moment what we can do to this query to make it useful in a group by. But right now, this is not allowed because we cannot have a column and some aggregate function outside of it as well. Okay. So let's give a couple of examples. So let's say I wanted to see how many properties cost more than $350 per month in rent, have a rent of higher than $350. I'm not necessarily wanting to know what properties have a rent higher than $350. I just want to know how many are there that have a rent higher than $350. All right. So I can do that using the count star. Select count star from the property for rent where the rent is greater than $350. And I'm going to get a single value, some number, and this would be basically the number of rows in the property for rent table that have a rent higher than $350. Okay. I might want to know how many properties were viewed between a certain date. All right. So count distinct property numbers. So this says, okay, only count distinct property numbers. So don't recount them. So if a certain property was viewed more than once, don't count it more than once. All right. From the viewing table where the view date was in May of that year. Okay. All right. We can have multiple aggregate functions in the same query. Again, as long as we don't have a separate column outside of it, that's fine. So we could say, I want to look in the staff table and I want to find out what the minimum, maximum, and average salaries are. Okay, we would get something like this. Okay. So I wanted to introduce those aggregate functions because the next week, Monday, we'll get into the group by of how to use those aggregate functions with group bys to do something that's a little bit even more powerful, where we'll be able to say, okay, I want to know what departments are there at the university and how many employees, how many teachers are there in each department, right? And I can do that using a single query that without having to go get all the rows and count them by hand. I just have the database do that for me. Okay. All right. So we'll get into group bys on Monday. But when we come back from the break, I will have that MySQL database up and running, and we will go through some examples today. Okay. If there aren't any questions, let me go back and check. Are there any questions? Nope, I don't see anything. All right. If there aren't any questions, then we will take our break now. I may need a couple extra minutes to get that MySQL stuff set up and done what I need to do. So let's give a lengthier break. Let's do 9:40. So, okay, we'll come back at 9:40 and rejoin this call and continue on with some examples. All right. See you guys in 12, 13 minutes.